In this video, we'll take a look at a quick conversion of number of rolls or number of hits to a percentage. Our goal will be to do this as quickly as possible with as little math and calculation as we can. No positions to analyze in this video, but just to demonstrate, we will show one position to show you just one of the examples of when it's critical to be able to do this. Here's a position where we have a huge lead as white. We've cubed our opponent, they've taken, but they own our 2-point and our 1-point. We roll the dice and we roll 6-4. The 6 is forced and we can't play a 4 up here. The 4 is also forced. The entire roll is forced. Now our opponent's on turn and they can hit us with a 4 or a 5. How many shots hit us? How many shots is that? And what is that as a percentage? If your opponent cubed you here, would you take? Should green cube in this position? What about, instead of 6-4, what if we rolled this roll, 6-5? The 6 is forced. We can't move the 5 here. The 5 is forced. Now we've left 2 checkers into 2 points that can hit us. How many rolls hit? Now, how many rolls hit will be the subject of shot counting part 1 and shot counting part 2. So that's a different subject. But how many rolls hit? What's a proper cube action here? If your opponent cubed you, would you take? Would you drop? A starting point of this is to look at how many rolls hit. Even if all you do is get an estimate, it's better than just guessing. Now we have learned that if we have about a 25% chance of winning, we should stop and really consider the take. This looks like a pretty scary position, but this will always be our default. If it's a take, we take. If it's a drop, we drop. Doesn't matter what the position looks like. And it's the ability to count these shots and then convert them. Most importantly, we have to convert them into a percentage that will help us form an opinion on what the proper cube action is. And if we're not doing this, then we're just guessing. So we really want to work on this. Shot counting is a separate issue, but when it comes to the number of shots that we determine hit these checkers, we want to convert that into a percentage very quickly, and that's the goal of this video. Okay, is there anyone interested in some fast shortcuts? Aslan, Jake, first to show up as expected. Alex is here. Smudge, we know Smudge wants this. Smudge, there we go. Don't hold up. Probably was eating. So we're going to start out by looking at all the rolls we have in backgammon with 2 dice. Now we know there's 36 rolls in backgammon, and what are these other numbers? These are our percentages. If we have 1 out of 36 rolls, it's 2.78%. 2, 5.56%. 15, 41.7%. 24, 66.7%. So where do these numbers come from? 1 is simply 1 divided by 36. 2, 2 divided by 36. 15, that number comes from 15 divided by 36. 24, 24 divided by 36. Pretty straightforward. But here we're doing this division, which takes a long time. It's not fun. And you don't have pencil and paper. You have to be able to do this in your head. So that's why we're looking for shortcuts so that we don't have to do this. Now, if you remember from our video when we're looking at the 8-9-12 rule, when we converted our pip lead into a percentage, we had some shortcuts. And here's that video for anyone who hasn't seen it. And we learned a nice way to start a shortcut is to take a number, stretch it to 100. And that gives us a lot of great shortcuts for finding these percentages very quickly and surprisingly accurately. Now, in this case, we have our 36 rolls in backgammon. That's what we're after. So 36. And in that video, we learned that the number 100 is a great number to work off of. So if we can stretch 36 to 100, the math becomes very easy. We also learned in that video, as good as 100 is, the next best numbers are 90 and 110, because we simply stretch our number and adjust plus or minus by 10%. So what are we going to do with 36? 36 times 3 is 108. That's pretty close to 110. So if we multiply by 3, and then we've overshot our 100, we're going to subtract 10%, we should get a reasonable estimate of these percentages. So we're going to multiply by 3, then we're going to subtract 10%. Let's do a few and see how this works. So let's say you have a position where there's 7 rolls you're looking at. So 7 times 3 is 21. 10% of 21 is 2.1. So 21 minus 2.1 gives us 18.9 when we're looking at 7 rolls. The actual answer is 19.4. So not too bad, about 0.5% off, but for a quick estimate, that's not bad. Our next number, let's look at 13. 13 times 3 is 39. We're going to subtract 10%, and that gives us 35.1. The actual answer is 36.1. So we're off by 1%. But when you don't need to be accurate, if your situation on the board is that you do not need to be accurate, that's pretty quick. In a few seconds, we got to within 1%. Let's do number 23. 23 times 3 is 69. We're going to subtract 10%, 6.9, and that gives us 62. It gives us 62.1. The actual answer is 63.9. Now we're getting closer to being about 2% off in our answer. One more example. Let's look at 35. 35 times 3 is 105. We're going to subtract 10%. Just move the decimal over, 10. And that gives us an answer of 94.5. And the actual answer for 35 is 97.2. Now we're off by almost 3%. Now we can do a lot better. There's a lot of shortcuts here that I'm going to show you. But one thing we can look at is if you only need a rough estimate, multiplying by 3, subtracting 10% will give you an idea of exactly where you are. And this also demonstrates that as these numbers got higher, our error increased. So we're going to address that in the next part and show you a super fast way to do almost all of these in just a matter of seconds. So here's how I do the percentages for the 36 rolls in backgammon. I'm going to simplify more than half of this chart by looking at some of the easy ones that we can do. It's going to eliminate almost all the math on those easy ones. And then we're just going to make a few adjustments on the other ones. And we have this, which worked, but it was a little inaccurate. We're just going to make a small adjustment to account for that inaccuracy and simplify everything. So let's first look at the very easy ones. 0 out of 36 is 0%. 36 out of 36 is 100%. Let's look at 9. 9 out of 36 is 25%. That's easy. 18 out of 36 is 50%. And 27 out of 36 is 75%. Now these are spot on numbers, and these are pretty easy. 36 divided by 4, 36 divided by 2. Same thing with 27, it's one of the multiples of 9. The other two numbers we're going to use is the 1 and the 2. Now 1 out of 36 is 2.78. 2.8 is close enough. You can even use 3 if you wanted. 2 out of 36 is just twice that. 5.56. You know what's close enough? 5.50. These are just one number away. So we have these easy numbers, and we have these two numbers. We're going to combine these two and eliminate half of this chart. So here's how I do that. We'll rewrite this just to make it a little neater. We have 0, 9, 18, 27, and 36. We have 2.80, or 3 if you wanted to round it up, and we have 5.50. We're going to use these two numbers to our known numbers that are super easy. So if 0 equals 0, 1, we're just adding 2.8. So 1 is 2.80. 2 is 5.50. But don't think of it as that. We just added 5.5. And this is how we can use that. We know 9 is 25%. So 1 more than 9, we're just going to add 2.8. 10 is 27.8. 11 out of 36, we're simply going to add the 5.50. So it becomes 30.5. Well, what would 8 be? We're simply going to subtract 2.8. So that gives us 22.2. What would 7 be? 2 away, subtract 5.50. 19.5. We know 18, 50%. 1 more than 18 is 19, add 2.8, 52.8. 20, 2 more than 18, 5.5, 55.5. 1 less than 18, 17. We simply subtract 2.8, 47.2, and 16. 2 less, we simply subtract 5.5. So that gives us 44.5. And we have, we'll do it on this one, 27. We know that's 75%. So 28, simply add the 2.8, 77.8. 29, we're going to add the 5.5, so it's 80.5. 1 less, 26. Let's subtract 2.8, so 72.2. 25, subtract 5.5, 69.5. Pretty easy. 36, we really don't use these numbers too much. Maybe not even at all, but we're going through all of them, so we'll do it. We know number 36 is 100%. One less would be 35. We have our 2.8, 97.2, and 34. We have our 5.5, 94.5. So because we have our known numbers, anything within 2 on either side is easy. We simply have to know these two numbers, 2.8 and 5.5, and that takes care of all of these. And if you look at the chart, if you look at what we've done, by knowing these four numbers, 9, 18, 27, and 36, and using our trick of these two numbers, 1 and 2, the 2.8 and the 5.5, we have eliminated that much of the chart, leaving us with only this. We've just eliminated over half the chart. Now, if you remember, this isn't too bad. It's a little inaccurate though. We're reducing it by 10, not by 8. So it's a little too much, so we have to add just a little back end to make this very accurate. So on our bottom line, we're going to do this, we're simply going to add a half. On this line, we're going to add 1. On this line, we're going to add 1.5. And on this line, we're going to add 2. And all this represents is a quick adjustment. We wish this number would be exactly 110, but it's not, it's close. And this small adjustment, if you want to add it, will increase your accuracy. So, for example, let's just do 2 of them. Let's do 13. So 13, we have our 9, our 18, our 27. It's not 1 or 2 away from that. So we're going to do it using this method, times 3 minus 10%. So times 3 is 39. We're going to minus our 10%, gives us 35.1, and then we're going to add 1. $36.1. It's not always like that. This one just happens to be spot on. 36.1. And let's do one more example. Let's do 22. So we have 22. Our numbers we're looking for are 9, 18, 27. It's not 2 away. It's close to 18, but it's not there. So we're going to use our method. Times 3 is 66. We're going to subtract 10%. So this gives us 59.4. And in our third line, we're going to add 1.5. So it gives us 60.9. The actual answer is 61.1. So that puts us within 0.2%. Now that's pretty accurate. So we have our easy ones. We have the ones that are 2 away on either side, leaving us with only 16 that we have to work toward. We have our times 3 minus 10%, and if you want, you can learn these adjustments, one for each quarter, if you want to think of it that way, to get your accuracy a lot better. Now this, again, our goal is to do this very quickly. So if you want to practice it, you should be able to do this very quickly with practice. And often, most of the time, you don't need a super accurate answer, which is a very important part. Now, for those who want to stay around to the end of the video, I'm going to go through all of the combinations on this page and do them live, and you can follow along just for practice. Let's go through our entire chart just for practice. We have our adjustments for the ones that need to. if we want a more accurate answer, we have our known numbers, 9, 18, 27, 36, and we have our easy adjustments from the numbers 1 and 2, giving us most of these. So we'll just go through all of them and practice. So 15. Closest number I'm thinking is 18, but it's not within 2, so we have to use the times 3 method. 15 times 3 is 45. We are going to subtract 10%, giving us 40.5, and we are going to add 1, so that gives us an answer of 41.5, and the actual number for 15 is 41.7, then 0.2%, and that's pretty good. Next number is 20. Now that's near 18. We know that 18 is 50%. This is 2 more, so all we have to do is add the 5.5, gives us 55.5. The actual answer is 55.6. Easy. 18. We know that one. 50%. 1. We know that one. 2.8%. 8. That's an easy one. We know 9 is 25%, and we're 1 less. So we just have to subtract 2.8. That gives us 22.2. Actual answer is 22.2. It's an easy one. 3. It's not near 9, it's not near 0, so we have to do it by the multiplication. Times 3 is 9, minus 10%, 8.1, and on the first line we're going to add a 0.5%, 8.6, and 8.33. It's the actual answer within 0.3%. 22, closest number is 18, so have to use our times 3 method. 66. We're going to subtract 10%, giving us 59.4. And we're on our third line, so we're going to add 1.5%. That gives us 60.9. So for 22, the actual answer is 61.1. We're within 0.2%. 2, we know 5.5, and 6. Nine is the closest, but it's not within 2, so we'll have to use our method. Times 3 is 18. We're going to subtract 10%, so that gives us 16.2. And on the first line, we're going to add a 0.5%. So our answer is 16.7, and the actual answer for 6 is 16.7. Gotta like that. Next number, 27, we know that one, 75%. 13, that's one of the in-between numbers. Multiply that by 3 is 39. Subtract 10%, gives us 35.1. Now we're on the second line, so we're going to add 1%. So our answer is 36.1. And the actual answer is 36.1. Perfect. Next number is 29. 27 we know is 75%. It's 2 more, so we're going to add 5.5. So that becomes 80.5. And the actual answer for 29 is 80.6. Next number is 7. We know that 9 is 25, and 7 is 2 less, so we're going to subtract our 5.5, giving us 19.5, and the actual number for 7 is 19.4, just where we want it. 35, we know 36 is 100, we're going to simply subtract 2.8, We never really use this number, but we're doing it just for fun, just for practice. That gives us 97.2, and the actual number is 97.2. Next one is 31. That's not near 36, not near 27. 31 times 3 is 93. We're going to subtract our 10%, so that gives us, what does that give us? 3, 6, 84, 83.7, is that right? Yeah, that's right, 83.7, and on the bottom line we're going to add 2%, that gives us 85.7 for 31, and it's 86.1, within 0.4 of a percentage on that one. 4 is one of those middle numbers. Times 3 is 12. We're going to subtract our 10%, bringing us to 10.8. It's on that first line, so we're going to add our 0.5, so it becomes 11.3%. Actual answer, 11.1, within 0.2 of a percent. Next number is 23, closest to 27, but it's not too away. 23 times 3 is 69. Going to subtract our 10%, so that brings us 62.1, and we're on our third line, so we're going to add 1.5%, giving us 63.6%. Actual answer, 63.9, within 0.3 of a percent. 11. 9 is one of our easy ones. We know that's 25%. We're 2 more, so we're going to add our 5.5, so that becomes 30.5. Actual answer for 25 is, actually the number for 11 is 30.6. Pretty easy. Our next number is 26. 27 we know is 75%. We're 1 less, so all we have to do is subtract 2.8. 72.2, actual number, actual answer for 26 is 72.2. Our next number is 12. 12 is an easy one, it's 1/3, but we'll do it the long way, just for practice. It's not close enough to 9 to use it, using our 2 numbers. So 12 times 3, 36. We're going to subtract our 10%. Gives us 32.4. And we are on our second line, so we're going to add 1%. 33.4 is our answer, within 0.1 of a percent. 14 is between 9 and 18 are known numbers. 14 times 3 is 42. We're going to subtract our 10%, so it gives us 37.8. We're on the second line, so we're going to add 1%. 38.8. And for 14, the actual answer is 38.9. Within 10%. Next number is 33. Not close enough to 36 to use our shortcuts here. So 33 times 3 is 99. We're going to subtract our 10%, giving us 89.1. And on the bottom, we're going to add 2%, so this becomes 91.1. And the actual answer is 91.7. A little off there, but it's not a number we usually don't use, this bottom line, but that's still, we're almost within 0.5%. Our next number is 24. 24 is another easy one because it's 2/3 of the way there, but it's not near 27. We'll do it for practice. 24 times 3 is 72. 72. Going to subtract our 10%, so that gives us 64.8. And we are on our third line, so we're going to add 1.5 to that. So this becomes 66.3. Actual answer is 66.7, easily within 0.5%. $17 should jump out at us because we know one of our numbers is 18. 18 is 50%, one less. 2.8 is our adjustment. So our answer is 47.2. Actual answer for 17 is 47.2. 19, same thing. 50% is 18. We're 1 over. We simply add 2.8. 52.8. Our actual answer is 52.8. 32, not near 36 or 27, so we have 32. Multiply that by 3, becomes 96. We're going to subtract our 10% from that, so that gives us 86.4. We're on the bottom line, so we're going to add 2, giving us 88.4. Actual answer for 32 is 88.9. 21, 18 jumps out at us, but it's not within 2. 21 times 3 is 63. We're going to subtract our 10%, giving us 56.7. And we are on the third line, so we're going to add 1.5, so that gives us 58.2. And the actual answer is 58.3. So in 10% there, 0.1% there. Next number is 5. That's in the middle of the chart. 5 times 3 is 15. Subtracting 10% gives us 13.5. And we are on our second line, so we're going to add 1%. So the percentage here is 14.5. I was looking at 15. So our number is 5. We're on the first line. We're going to add 0.5, so it becomes 14.0, and the actual answer for 5 is 13.9. We're within 10%. And just a few more here. We have 28. We know 27 is 75%. We're 1 higher, so we're just going to add the 2.8, 77.8, and the actual answer for 28 is 77.8. And we have 16. We know 18 is 50%, and this is 2 less, so we're just going to subtract our 5.5. 44.5. Actual answer for 16, 44.4. 30. 27 is the closest, but it's not within 2. So we have 30 times 3 is 90, minus 10% gives us 81. We're on the bottom line, so we're going to add 2. That becomes 83%. And the actual answer for 30 is 83.3. 0.3%. 25. We have our 27. We know that that is 75%. We're 2 less than our 27, so we just simply subtract our 5.5, giving us 69.5. And the actual answer for 25 is 69.4. Within 10%. 2 more to go. 3 more to go. 10, we know 9 is 25%. We're 1 more, so we're simply going to add 2.8, 27.8. Actual answer for 10 is 27.8. 34, we know that 36 is 100%. Subtract 2, 5.5, gives us 94.5%. Actual answer for 34 is 94.4. And the last one, 9, 25%. So with a little bit of practice, you can go pretty quick. Again, if you look at this, most of these, the ones that are closest to our known numbers, that removes over half of this chart. And if you don't need super accuracy, multiply by 3, subtract 10% will get you right in the ballpark. And there's so many different positions where you need to know what your shots are, what your number of rolls are as a percentage. So this is something you're going to use in multiple positions throughout all the years that you're playing backgammon. And to be able to do this as fast as you can is really, really handy to do. And having flashcards, make a chart for yourself, see how fast you can do, get better and better with time.